Alright, so today we're going to look at trigonometric form of complex numbers. Alright, so let's go ahead and get started. So complex numbers, you've probably seen this already in algebra. You've seen complex numbers in the form a plus bi. So what we're going to look at today is we're going to look at complex numbers in trigonometric form. All right. So it says the absolute value or modulus of the complex number a plus bi is defined as, or is defined by, the absolute value of a plus bi is equal to the square root of a squared plus b squared. All right. That's the absolute value. So let's go ahead and get into the first example. It says graph each complex number and find its absolute value. All right, so let's look at our first problem. So let's go ahead and draw our axis. Now, if you remember in college algebra, a complex number, it has a real part and it has an imaginary part. So the real part is the 3 and the imaginary is the 4. All right. So if we look at this, let's put our tick marks on the axis. So this our horizontal axis, and we've got a vertical axis. So we look at this and we know this as the x-axis and y-axis. That's what you've learned all through algebra and all that stuff. But when we're graphing complex numbers, this is the real axis and this is the imaginary axis. All right. So it's like plotting a point. All right. So we can see 3 is the real part. So we go to the right 3. And then 4, that's the imaginary part. So for the real part, we go over 3, and the imaginary part, we go up 4. And that's where we plot the point. All right, so that's graphing the complex number. Now they want us to find its absolute value. All right, so how do we do that? Well, the absolute value of 3 plus 4i, that's just the square root of 3 squared plus 4 squared, which that is the square root of 25, which equals 5. All right. So now let's look at the next one. We got 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4. 1, 2, 3, 4. All right, so we're plotting the real part, imaginary part. Remember the horizontal axis? That's the real axis, and the vertical is the imaginary axis. So the real part, that's -2. So we go to the left 2. The imaginary part is -1. B is -1. A is -2. B is -1. So we go to the left 2 and down 1. And there's that one plotted. And then we want to find the absolute value of -2 minus I. That's the square root of -2 squared plus -1 squared. And so that is going to be what? Square root of 5. All right. So hopefully that made sense. That's pretty easy, just like plotting a point and then, a squared plus b squared, take the square root of it. All right, so let's look down here at this definition we got here. All right, so here's the big stuff here. Trigonometric form of a complex number. So the trigonometric form of a complex number, if z is equal to a plus bi, okay, it's in this form like you saw in college algebra, is a complex number, then the trigonometric form of z is z equals r times the cosine of theta plus I sine theta. All right, this right here, this r cosine theta plus I sine theta, that's the trigonometric form of this complex number right here. So where r is equal to a squared plus b squared, so that's how we find r. Yeah, I mean, you might have guessed by now, we're going to convert from this form to this form, and we're going to convert from this form back to this form. All right, so r is equal to a squared plus b squared, and theta is an angle in standard position. So remember what standard position is. That's where the vertex is at the origin, the initial side lies along the positive x-axis, and then we can rotate however, wherever we need to for the terminal side. So theta is an angle in standard position whose terminal side contains the point AB. And an abbreviation for this r cosine theta plus I sine theta is RCIS theta. So, instead of, when you're writing these complex numbers, if you don't want to write it all out like this, you can abbreviate it to this form here. Now, this next statement I have, this is to find theta. Now, you might look in some textbooks and they find theta a little bit different than this. They might use sine or cosine to find it. I just like to use tangent. I use tangent theta is equal to b over a, and that's what I use to find theta. Yes, you can use sine, you can use cosine. Okay. So I mean, just think of it this way. A is equal to r cosine theta, and b is equal to r sine theta. And if you solve for cosine, if you solve for sine, well, cosine is what? A over r. Sine is b over r. You could use that to find theta, or you can use this tangent theta is b over a. Okay, it really doesn't matter. I like to use tangent. All right, so let's look at this. Write each complex number in trigonometric form. Well, I really wrote going on this one, didn't I? All right, so write it in complex form. So we want to write it in the form r cosine theta plus I sine theta. So what do we need to find? We need to find r, and we need to find theta. Okay, so let's find r first. So r is equal to, remember, r is a squared plus b squared. So a, that's -2 square root of 3 squared plus b squared. Well, what's b? B is 2. Remember, b is the number in front of I. So that's 2 squared. And so what does this equal? Well, -2 squared is 4. Square root of 3 squared is 3. Okay. See, all I do here is I square the -2, and then I square the 3, and then I'll have to multiply them together. And so that's the square root of, that's what, 12 plus 4 is 16, which equals 4. So there's r. Now I need to find theta. All right, so I've got tangent theta is equal to b over a, which is -1 over square root of 3, which is -square root of 3 over 3. There's tangent theta is equal to -square root of 3 over 3. So I'm getting tangent is equal to a negative number, right? Whenever I take the tangent of this angle, I should get a negative number. Well, now that starts to make us think, when we look at tangent is negative in the second and the fourth quadrant. So what's theta? What's theta? Well, you have to graph these things, okay? This complex number here, this -2 square root of 3 plus 2i, you've got to graph it, all right? And luckily we know how to graph it because that's the first example we worked. So let's do that. So if I plot -2 square root of 3 plus 2i, so a is negative, so that means I move to the left. B is positive, so that means I go up 2. All right? And there's theta. All right? Now, notice I didn't put the tick marks like I did on the first example, because I don't really care exactly where the point is. I'm not really that worried about the exact location. What I'm worried about is what quadrant is it in. That's really all I care about, is what quadrant am I in. All right, so now, well, what's theta? Well, if you remember back earlier in your trig class, you learned about reference angles. So we need to find the reference angles. So there's your reference angle. I just used the theta with a little mark right there to represent my reference angles. You know, in other trig books, I know I've seen they've used this, you know, I've seen this, and then this with the little mark there. I just used this one, okay? It doesn't matter which mark you use. All right, so let's find the reference angle. So I get tangent theta prime. Now remember, whenever you take the sine, cosine, or tangent of a reference angle, it's always positive, right? Because the reference angle is in the first quadrant, and anytime you take the sine, cosine, or tangent of an angle in the first quadrant, it's positive, because all trig functions are positive in the first quadrant. So this is going to give me the reference angle is equal to what? 30 degrees. All right. So hopefully all this is making sense. All right. So this is 30. And so that means theta is equal to what? 180 minus 30, which is 150 degrees. All right. So now I have R and I have theta. And so all I do now is plug it into this. So I get this is equal to R times cosine theta plus I times sine theta. And there it's written in trigonometric form. All right, let's do another one. All right, so I've got 3 minus 2i. So I need to find R and I need to find theta. So let's find R first. So R is equal to the square root of a squared plus b squared. All right, so this is equal to the square root of 9 plus 4, which is the square root of 13. So there's R. Now let's find theta. So I get tangent theta is equal to b over a. All right, so there's tangent theta. Tangent theta is equal to negative. I need to come over here, always come over here and plot and graph your complex number. So 3 minus 2i, a is positive 3, b is negative 2. So I go to the right 3, down 2. And like I said, we don't care about the exact location. All we're really worried about is what quadrant is it in. All right, and there's my reference angle. So let's find the reference angle. So tangent theta prime is equal to positive 2/3. All right, so I've got to punch this in my calculator. Whoop. It's not equals there. So I get theta prime is equal to, let's see, second tan, inverse tan of 2 divided by 3. That is, we'll round it to 1 decimal. That's 33.7 degrees. So there's my reference angle, 33.7 degrees. And so theta is equal to, well, what's that? That's 360 minus 33.7 degrees. And so that is going to give me theta is equal to 326.3 degrees. So there's R and there's theta. So trigonometric form is R, which is square root of 13 times cosine theta plus I sine theta. All right, and there's your answer. There's the trigonometric form. Now, if we wanted to, if we were lazy about it, well, no, I don't guess I would say lazy, but if we wanted to write it in that abbreviated form, we could write it how? That would be square root of 13 and then the CIS 326.3 degrees. So either one is acceptable, okay? This is written out, this is abbreviated. Just like up here, if we wanted to, we could write this as 4 and then either way. Write it written out or write it in the abbreviated form. You're in my class, I don't care which one you write it in, okay? I'm happy if you get it right, all right? But, check with your teacher to make sure you can write it in either form. All right, so that was going from the a+bi form to trigonometric form. What about going the other way, from trigonometric form to the form a+bi? Let's do that. And we've already worked the more difficult types of problems. Going from the a+bi to the trigonometric form, that's the more complicated one. That's more complicated than going from trigonometric to the a+bi. And you'll see. Let's go ahead and do these examples. So all this is just square root of 2 times, well, what's the cosine of pi over 4? That's square root of 2 over 2, right? Square root of 2 over 2. Cosine of 45, remember, pi over 4, that's the same as pi over 4 radians is 45 degrees. That's square root of 2 over 2 plus I times sine of pi over 4, that's square root of 2 over 2. And then we just distribute the square root of 2. So that's going to be 2 over 2 plus I times 2 over 2, which is 1 plus I. And there's your answer. So you see, that was pretty easy there, wasn't it? That wasn't bad at all. All right, so what about this one? Oh, goodness. So we got 3.6 times, now we got cosine of 143. So this we have to plug into our calculator. And I tell you what, let's just plug it all into our calculator. So what I'm typing in my calculator right now is I'm typing in 3.6 times, and then I'm hitting times, cosine of 143. I just typed it in because I'm going to multiply 3.6 times this, and then I'm going to multiply 3.6 times this. So I just put in 3.6 times cosine of 143, and I hit equals, and that gives me negative 2.875. I'm just going to round it to 3 decimal places. All right. And then I plug in the next one. So plus, and then 3.6 times sine of 143. And that leaves me with 2.167 I. And there's your answer. So you can see going from trigonometric form to a+bi form a lot easier than going the other way. Okay? So hopefully all that makes sense. Okay? Hopefully all that makes sense. All right. Now, what about multiplying and dividing these things? Let's take a look at that. So the product and quotient of complex numbers. So if we have complex numbers in trigonometric form, so if z1 is equal to r1 times cosine theta 1 plus I sine theta 1, and z2 is equal to r2 times cosine theta 2 plus I sine theta 2, then z1 times z2, so what I'm doing, I'm multiplying this and this together. So if I multiply them, that's r1 times r2, so this r1 times r2 times, and then the cosine of theta 1 plus theta 2 plus I sine theta 1 plus theta 2. That's it. So you multiply the two r's together, and then you add the angles. And then guess what? Look how easy the division is. And z1 over z2 is r1 over r2. So do r1 divided by r2. And then I subtract the angles. Theta 1 minus theta 2 plus I sine theta 1 plus theta 2. That's multiplying and dividing them when you got them in trigonometric form. All right. All right, so let's take a look at these examples here. So they want us to multiply them, and then they want us to divide them. All right. And I didn't write all of the directions, and they want us to express answer in a plus bi. Okay, so that's how they want that answer written in a plus bi form. All right, so let's go ahead and multiply these things together. So I've got, let me change my color. So z1 times z2 is equal to 6 times 2 times cosine of 2.4 plus 1.8 plus I sine of 2.4 plus 1.8. All right, so I'm just writing it all out, plugging everything in. I mean, you could do this in your head. You could write 12. You could write 4.2 and 4.2. I'm just writing it all out so you can see it. All right, so this is 12 times, and that's going to be cosine of 4.2 plus I sine 4.2, and there it is. You see how easy that is? But now they just want us to put it in the form a plus bi. Well, how easy is that? Look, we just did that up here. See, going from trigonometric form to this form. That's all we're doing now. All right, so we'll plug this into your calculator. So I'm just doing 12 times cosine of 4.2. I'm putting that in my calculator. That is negative 5.88. And then 12 times sine of 4.2. So that's going to be negative 10.46i. And there's your answer. Okay. Let me write this up here so I'll have enough room to divide them. So I can see that I might run out of room there. Let's just put the answer up there. All right, and that's all it is. Now, if you're working along with me on these problems, if you're working along with me and you're saying, but I'm not getting that answer when I plug it into my calculator, I'm not getting that. All right, so this is where you got to be careful. Now, notice up here, when you plug this into your calculator, this angle is in degrees, so your calculator needs to be in degrees. But down here, we're not in degrees, we're in radians. So when you punch this into your calculator, make sure you're in radian mode. All right, so be careful, pay attention to that kind of stuff. All right, now let's do z1 over z2. So that's r1 over r2 times the cosine of 2.4 minus 1.8 plus I sine of 2.4 minus 1.8 why did I write R1 over R2? That's 2.4 over 1.8. Let's go ahead and plug the numbers in. All right, so that's, oh my goodness. Man, I'm having a time with this problem so far, aren't I? That's 6 over 2. How about that? Is that better? That makes more sense, doesn't it? Not that I guess when I was writing this, I was looking at the 2.4 and the 1.8 there. It happens sometimes. I'm sure you've made that mistake too. And so that's going to be 3 times the cosine of 0.6 plus I sine 0.6. And then we just distribute 3 times cosine of 0.6. That is going to be 2.48, and then plus, and then 3 times the sine of 0.6, that's 1.69. And there's your answer. All right, so hopefully that's good. See, it's easy. All you're doing is multiplying, dividing, adding, and subtracting. That's all you're doing. Basic arithmetic. And you're punching stuff in your calculator. All right, don't make this more difficult than what it is. Okay, it's not that bad. All right, so let's look at this one. Same thing. Find Z1 times Z2 and Z1 over Z2. Let's find both of them. But what they want us to do in this example is they want us to use trigonometric form to multiply them and trigonometric form to divide them. So let's do that. One thing that does, that gives us practice on finding, that gives us practice on converting it to trigonometric form also. So first thing we need to do is we need to convert them. So first, let's convert Z1. Let's put that in trigonometric form. So here we've got converting Z1. So let's do that first. All right, so R is equal to the square root of negative 2 squared plus 2 square root of 3 squared. And so that's going to give us the square root of 4 plus 2 squared is 4, square root of 3 squared is 3. So that's going to give us 4. And actually, let's go ahead and do this. That's R1, right? We're converting Z1. Let's label that R1. All right, now let's find theta. So tangent theta 1 is equal to what? B over A. So that's 2 square root of 3 over negative 2, which is negative square root of 3. All right, so what do we want to do here? We need to find what? We're going to need to find our reference angle, aren't we? So let's see. I'm going to draw it real small right here. So first, let's plot the point. So that's negative 2 square root of 3. So negative 2, positive 2 square root of 3. That's right here. We're in the second quadrant. There's theta 1. Well, we need to find the reference angle. And so tangent, let's do theta 1 prime. Theta 1 prime. So that's the reference angle for theta 1. That's equal to square root of 3, which that tells us theta 1 prime is, well, the tangent of what is square root of 3? That's 60 degrees. All right, so theta 1 is 180 minus 60, which is 120. And so this gives us Z1 is equal to R1, which is 4, times cosine theta 1, which is 120, plus I sine 120. All right, so I converted it to trigonometric form. All right, now converting z2. So let's convert this one. So I've got r2 is the square root of square root of 3 squared plus b is 1 squared, right? That's understood to be a 1 in front of the I. So that's the square root of 3 plus 1. That's 4. So square root of 4 is 2. So r2 is 2. All right. Now let's find theta. So I get tangent theta 2 is b over a. So that's 1 over square root of 3, which is square root of 3 over 3. That's positive, okay? But just because it's positive doesn't mean it's in the first quadrant. We got to plot it first. So if we plot this, that's positive square root of 3, positive 1. There you go. So we are in the first quadrant. There's theta 2. And so this tells us theta 2 is, what is that? 30 degrees. See that? So I get z2 is equal to 2 times cosine theta 2, which is 30 degrees, plus I sine theta 2. All right. Now, I know earlier in this problem I said just because this equals positive doesn't mean it's in the first quadrant. Well, this one was in the first quadrant. But look, if you had a complex number like, say, -2 minus 2i, something like that, well, if you plot that, that's over here in the third quadrant, right? And you would get tangent theta is equal to what? -2 over -2, which that's positive 1. See, I get tangent theta equals a positive number, but it's in the third quadrant. That's why it's so important to graph these things. Okay, you've got to graph them. All right, so now I have them both in trigonometric form, and now we're just going to multiply and divide like we did the problem up here. Okay. All right, now if you're still watching the video, don't leave just yet, because I'm going to show you something else. I'm going to show you something about this also. All right, so let's find z1 times z2. So that's 4 times 2 times cosine of 120 plus 30 plus I sine 120 plus 30. So this is going to be 8 times cosine of 150 plus I sine of 150. All right. So what do they want us to do? They want us to convert this. They want us to write this in the a plus bi form. Okay, this would be your answer in trigonometric form, but they want the answer in a plus bi form. So I've got 8 times. So remember, to convert this, we're going to take the cosine of 150, and we need to find the sine of 150. Well, what is that? Well, let's use reference angles. So there's 150, right? There's my reference angle. My reference angle is 180 minus 150, which is 30 degrees. All right. So let's look at this. The cosine of 150, well, the cosine of 30 is what? Square root of 3 over 2, right? We're in the second quadrant, so that's negative. And then plus, and then the sine of 30 is 1/2. I'm in the second quadrant, sine is positive, so it's positive 1/2. And then, and times I. And so this is going to be what? Distribute the 8, that's -4 square root of 3 plus 4i. And there's your answer. All right, so remember, all this is, remember when you're finding the cosine or sine of an angle that's in another quadrant, how you used reference angles to do that? The reference angle, remember the reference angle gives you the value, and then you've got to go and see what quadrant you're in to see if it's positive or negative. So remember that was back earlier. You're supposed to already know how to do that. All right, so now let's find z1 over z2. Let's see what we get there. All right, so let's see. I'm going to put a red line under these so I can see them easier. That's what we're dividing now. So that's going to be 4 over 2 times the cosine of 120 minus 30 plus I sine 120 minus 30. So that's going to be 2 times cosine of 90 degrees plus I sine of 90 degrees. Now we need to know what the cosine and sine of 90 degrees are. Well, that's going to be 2 times 0 plus 1 times I. And so that's going to give me 2I. And that's your answer. All right. So all I did the cosine of 90 is 0, the sine of 90 is 1, and then I distribute the 2. All right, so what I want to show you now is, so honestly, the way that we work these, we did extra work. I don't know. Honestly, I think it's easier. It's easier to multiply them and divide them when they're in trigonometric form. But you see all this work that we had to do first to convert it? Converting's not that bad, I don't think. But let me show you this. You see this, the two complex numbers, they're written in the form a+bi. I wonder what would happen if we would just multiply these out instead of converting them and then doing this. I wonder what would happen. Well, let's come down here and let's do that. Let's at least multiply them. So, we had z1 is negative 2 plus 2I square root of 3. Whoop. And we had z2 is equal to square root of 3 plus I. All right, so let's just multiply them. So z1 times z2, that's negative 2 plus 2I square root of 3 times square root of 3 plus I. All right, so let's multiply them. When we worked them, what did we do? First, we converted this to trigonometric form. Then we converted this to trigonometric form, and then we multiplied them. Let's not convert them to trigonometric form and just multiply them together. So remember, full method. So first, so that's going to be negative 2 square root of 3 outside, so that's minus 2I. Inside, so this is 2I square root of 3 times square root of 3. Well, square root of 3 times square root of 3 is 3, right? And then 3 times 2 is 6, so plus 6I. And then multiply the last. So that's going to be plus 2 square root of 3 times I squared, right? I times I gives us I squared. Now, remember, let's just write it all out. That's going to be what? Plus 4I, negative 2I plus 6I, and then plus 2 square root of 3. And I squared, remember, that's negative 1. And so this is going to be negative 2 square root of 3 plus 4I minus 2 square root of 3. Well, negative 2 square root of 3 minus 2 square root of 3 is negative 4 square root of 3 plus 4I. And that's what we get if we don't convert it to trigonometric form first. If we just multiply them out, we get what? Negative 4 square root of 3 plus 4I. Let's look. Oh, look at that. Negative 4 square root of 3 plus 4I. Same thing. All right. All right, so, how should you work them? Should you convert them to trig and then multiply them, or just multiply them out like this? That depends on what your teacher tells you to do. Do what they tell you to do, okay? And then I'm not going to work through the problem. I'm not going to work through this one, but I'll write it up for you. So if they wanted you to do z1 over z2, if they wanted you to divide them, you could do that as well without converting them. And like I said, I'm not going to work it out. but I'll get you started on it. Remember this? Well, what do? You multiply by the conjugate. Whoop, that's not right. You multiply by the conjugate of the denominator. Remember that? And then once you do that out, you'll get 2i as an answer. So if you're sitting there, you're bored or something, have nothing to do, pull this out, write this problem down, multiply it out like that, and see if you come up with 2i. And there's your answer. Okay, but like I said, I'm not going to do the work. But that's how you would do it, and it would come out the same. All right, so here we have a theorem, complex conjugate. So the conjugate of the complex number r cosine theta plus I sine theta is r cosine negative theta plus I sine negative theta. And so what they want us to do here is find the product of 2 cosine pi over 3 plus I sine pi over 3 and its conjugate using multiplication in trigonometric form. So what they want us to do is they want us to multiply this times its conjugate and see what we get. All right, so let's do that. And by the way, this is the last problem of the video. All right, so I've got 2. Now let's do this. Let's go ahead and let's write them down. So we got 2 cosine pi over 3 plus I sine pi over 3. All right. Now let's write its conjugate down. So the conjugate is 2 times cosine negative pi over 3 plus I sine negative pi over 3. And so we want to multiply them together. Well, how in the world do we multiply them together? Well, we've done that already, haven't we? So that's going to be what? 2 times 2 times cosine of pi over 3 plus negative pi over 3 plus I sine pi over 3 plus negative pi over 3. And so that's going to give us 4 times cosine of 0 degrees plus I sine of 0 degrees. And so that's going to be 4 times the cosine of 0 is 1 plus I times the sine of 0 is 0. And so that just leaves us with 4. All right. Leaves us with 4. And look, this right here. All right. So look, we've got our answer 4. That's the answer 4. Now, what if we take this? Let's take this. Let's convert it to the a plus bi form and multiply those conjugates together. And let me show you how that works out. So if we take 2 times, and then we got the cosine of pi over 3, or the cosine of 60 degrees, that's 1/2, plus, and then we have the sine of pi over 3, or the sine of 60 degrees, that's what, square root of 3 over 2. And then we distribute, that's 1 plus I square root of 3. So if we multiply the 1 plus I square root of 3 times its conjugate, that's 1 plus I square root of 3 times 1 minus I square root of 3. Okay, just going to multiply by the conjugate. Remember, when it's in that a plus bi form, the conjugate, you just change the sign in the middle. Well, remember, there's a property that says a plus bi times a minus bi. Now, all this you learned in algebra is a squared plus b squared. All right, so that's just what? 1 squared. A is 1, b is square root of 3, so that's square root of 3 squared. So 1 squared is 1, square root of 3 squared is 3, and look at there, you get 4. See, it's the same answer. Wow, isn't that pretty neat? So you see, it's just a matter of, are you working with the complex number in the a plus bi form, or are we going to work with it in trigonometric form? And you might be thinking, well, this is kind of, this is stupid. Why can't I just Why not just keep it like this? Why do I even need to convert it to trigonometric form? Well, the next video in this playlist, you'll see why. All right. So just to give you a little preview, what if you had something like this? If you had a complex number and you wanted to raise it to the 12th power, what are you going to do? Well, 1 plus 2i times 1 plus 2i times 1 plus 2i, so on, 1 plus 2i. You got 12 of these. You got to multiply this times this, and then whatever you get for that, multiply that, and then whatever you get there, multiply it times the next one. You can see that's going to take forever. Well, if we take this and we convert it into trigonometric form, we can work it real easy. All right, so trigonometric form has its advantages. All right, so that's all of the video. I hope it helped. Give me a like, share, and subscribe. Check out my other videos. Thank you for watching, and I'll see you later.